When we dissolve a transition metal salt, for example cobalt nitrate in water, the water molecules don't simply form a hydration shell around the positively charged cobalt ion, they coordinate themselves in an octahedral arrangement. Each oxygen donates a lone pair of electrons to the central cobalt ion. So in fact, we have a solution of hexa-aqua-cobalt-2 ions and nitrate ions. The 6 coordinating water molecules are behaving as ligands. Water is an example of a monodentate ligand, with each ligand making one dative covalent coordinate bond to the cobalt. Ligands can be negatively charged ions or neutral molecules, but they all have lone pairs of electrons which they're free to donate. 1,2-diaminoethane is an example of a bidentate ligand. It donates 2 pairs of electrons to the central metal ion so that each ligand is forming 2 coordinate bonds. In this complex ion, we see cobalt coordinating with 2 chloride ion ligands and 2 ligands of 1,2-diaminoethane. Once again, this is an octahedral-shaped complex. The ethylene diamine tetraacetate ion, or EDTA for short, is an example of a polydentate or chelating ligand. In this case, it's hexadentate. The ligand wraps around the central ion using the lone pair of electrons on the 4 oxygen atoms and the 2 nitrogen atoms to make 6 dative covalent bonds. The complex formed is often called a chelate. Crunch chemistry. Everything you need to know about transition metals.